Let me know when we are live, yeah?
We're live.
Okay.
Welcome to the demo day and closing ceremony. My name is Erica Kang, and below Nicole, and we are the organizers of HackAtom HCMC. It is a great honor and pleasure to be here with all of the talented teams and players in the blockchain space. So thank you for being here. So HackAtom HCMC has originally been set off as an offline hackathon, but due to COVID situations in Ho Chi Minh City, we had to, turn the event online and extended the hacking period. It was a lot of challenging moments, but we are very thankful to have wonderful partners and talented participants who support us today. So Nicole, do you want to have a quick hello?
Hi, everyone. Thanks for being here. And we are very excited to show you, what we've got from the Cosmos HackAtom. So let's get this going.
Great. Yeah. So first of all, we have the sponsors. We really honestly couldn't have done it without them. So I'd like to give a huge thank you to our sponsors who made HCMC, HackAtom HCMC possible. So Terra was our platinum sponsor. Thank you so much. Doka Capital, our gold sponsor, Rizun and Cosmos Station as silver sponsors, Desmos and Persistence as bronze sponsors. So we are extremely grateful for your endless support, even for today. So thank you so much. And next, we will introduce the judges who will evaluate the work by participants and our lovely Chango and Chained, Billy and Brian, Do Kwon, Dennis, and Chan Van Kui. Peter, thank you so much for being here to participate and support us. We were also supported by our wonderful local mentors, and a huge shout out to them. They have been very supportive and participating in our mentoring sessions. So thank you so much. Okay, next. These are challenges that we briefly introduced in our opening ceremony as well, but there were four large categories for the challenges. So yeah, there was the tokenization challenge, DeFi challenge, IBC challenge, and golden challenge. The total prize pot was $20,000 worth in atoms. The first prize will receive 10K, one second prize will win 6K, and the two third prize winners will win 2K each. So that is our total prize pot. And now, Nicole, do you have anything to add to this, or should we get the participants on stage and do the demos? That's good. Very exciting. Very exciting. Thank you so much. And it's our demo time, and we have this order, and we have Bifrost team, and the first time, and each team has about 5 minutes roughly to do a quick demo and presentation. Then if the judges have some questions, they will ask at the end of the presentation. So first of all, is Bifrost team ready? You want to get on stage?
Yeah.
Hello.
Hi. So shall I present my screen?
Yes, you can share your screen.
Yeah. Hold on a second. Sure. Right. Can you see me? See my screen? Yeah?
Yes.
Yeah. Okay, so I'll begin, and if I have internet issues, I'm sorry for that. If it fluctuates.
Yeah,
right,
can you turn on
so
the presentation mode?
my project. Yeah, sure. Yeah, good now?
1 second.
Yeah?
Yes.
Yep. Good to go.
Yeah, okay. So my topic, Bifrost, it's a peg zone. I have created a peg zone. I implemented the golden challenge. So let's see what is Bifrost. So Bifrost is a full duplex bridge that connects the Tezos blockchain to the realm of Cosmos blockchain. And its sole purpose is actually facilitating the interchain token transfer. So it has four main functionalities. One of them is send tests from Tezos blockchain to Cosmos blockchain. Second, send Bifrost muters representation of Tezos Cosmos blockchain to Tezos blockchain. Third, send Cosmos native token, Genom token to Tezos blockchain, and fourth is send Cosmos token that is stored in token back to the Cosmos blockchain. Right. So it has three moving components. First is a Cosmos blockchain or a peg zone where the token gets minted or burned. The next is the two sets of smart contract. They are called Bifrost smart contract set. It has two smart contract. One is Bifrost contract and that is FA12 contract. And third is a relayer, which I said the Bifrost relayer that continuously watches on the Tezos blockchain and fetches the storage of the Tezos blockchain and relays the transaction to the Cosmos blockchain via messages. So let's see or look at the algorithm of how to send Tez from Tezos blockchain to Cosmos blockchain, right? So to send Tez from Tezos blockchain to Cosmos, first we send Tez to our Bifrost contract set where it gets locked and a transaction is created that is stored in the map of the storage, and the transaction is like a record of smart pi that looks something like this, where you have transaction id value, and transaction id is the main mac key that extracts the transaction, right? So relayer, it continuously watches over the storage. If a new transaction is in the storage, then the relayer fetches it, it decodes it, and then creates a receipt transactions type, and then there is create receipt transaction type messages, and it sends it to the peg zone. The peg zone then sends back the verification packet, and the verification, if it's successful, then a success code is sent, and if it failed, then a fail code is sent, and based on that a token is minted in case it's success, and in case it's failed, it's not minted, and the token is unlocked in the Tezos smart contract. And once you have Bifrost muters reflecting the balance of users account in the Cosmos blockchain, all right, with IBC we can transfer it to any Cosmos blockchain. So this drawing is not to again repeat the algorithm. Actually, this entire implementation is without the signature verification. So signature verification will be happening right over here. If it actually goes to the production level, then this will be happening right over here, and the signature creation will happen before the transaction is sent to the Tezos blockchain mostly, or another thing it can happen is before passing it down to the relayer, because there is no make signature. We cannot manipulate secret key in Tezos smart contract, right? So let's see quickly how to send Bifrost muters that is in the Cosmos blockchain back to the Tezos blockchain. So there's a command called send to Tezos, where you have Tezos receiver, amount, and the denom. So denom can be either Bifrost muters or token. So when you issue this command, the Tezos address is passed, is checked if it's correct address, and then the balance of the message creator is checked, because his balance we are going to send it back to the Tezos blockchain. So if the balance is sufficient, then it's burnt, and message is sent in case of Bifrost muters to unlock in case of the token, the message is being used. So it's minted or allowed for and then fail or success message fail or success message is let if it's fail, then token is minted back, and if it is the thing happens in the so this is system working. So the signatures will be happening over here in the peg zone, and right over here the signature will be compatible with signature method of the smart contract. And same will be again same thing. So don't bore you with the same algorithm.
I think we lost this. Oh, there we go. The network might be a little bit unstable, so please understand. I am very sorry for this. Is the online beauty of these online live shows, but hopefully we'll get the speaker back on track. Oh, please.
Should have been unlocked for transaction, and because the storage process engine actually processes and decodes the storage to a Golang type, which can then be used to form a message. Right. So what's next on this? I think I'll spend a little bit time on this. First is signature verification to be implemented by creating the receipt transaction and creating the receipt by 12 transactions. Then the block finality threshold needs to be implemented while transferring from Tezos chain to Cosmos chain. Is already implemented while transferring from Cosmos to Tezos chain, but the signature system is not produced because those doesn't seems like any library can
I think while we are waiting for Bifrost to come back, maybe the judge, if you could just look at his submission and then prepare the questions, I think that would be great. We're gonna wait for him to come back. Okay. Yeah, I think that's maybe 5 minutes up for Bifrost. So we're gonna move to the Q&A section for Bifrost now. So Church, if you have any questions, please just message us, and then we'll put you on stage. Right.
Yeah. I'm sorry, I got connected. Yeah.
Yeah.
Sorry about that. Yeah.
Okay. I think we're working on
like,
yeah.
Yeah. Okay. Do you have like 1 minute to give an ending?
Okay. Sure.
Yeah. So So 1 second. I'll just present the screen real quick. Okay.
What about turning off your video?
Yeah.
Yeah. Sure. I'll turn it off. Yeah. Good now.
Yes. Let's see. Okay.
Yeah.
Great.
Okay. So final thing. So signature verification needs to be implemented. Block finality is already implemented, and create signature needs to create a signature that is compatible with check signature of Michelson. And finally, the Michelson smart contract cannot manipulate secret keys, so we have to do an off-chain signing in case of transaction. Create receipt transactions and create receipt FA12 transactions. And there's a small tool for doing that. That's for a glimpse in the future. I have just created. You can check it out there. So right with that, I'd like to one more thing. This relayer will be using RPC or API rather than like system command execution, so it's very close to transport layer. So okay, with that, I'd like to conclude. Thank you.
Thank you so much.
Thank you.
Yeah, thank you.
Yeah.
Mm-hmm.
Are there any questions?
Yeah, you can turn the video back on now.
Questions. Mm-hmm. Yeah.
Okay.
Oh, okay. Peter has a question.
Yeah, sure.
Okay, hello. I assume you had the problem. Okay. Hello, everyone.
Hello. Yeah.
Hi.
Okay.
Yeah.
Hi. You had a problem with the signature verifications on smart piece. Do you try another language for programming smart contract like Lego, Molly, Phi to solve the problem? In some article I read, the first choice with the simplicity and active support community.
Mm-hmm. Yeah, it's the right. It is by the person who's having zone who actually wants to send transaction to the peg zone. He is actually operating the relay. He needs to connect the layer for that. And
I
they
think it's better.
to run both Tezos and Flex. Yeah, they need to run both Tezos clients. I mean, they only run Tezos node. Basically, it can connect to Tezos by Tezos client RPC, but they really do need to, run the.
Satasi, I think maybe it's better that you turn off your video again and take us
Answer the question.
Answer the question
Yeah,
again.
yeah.
We can't catch you.
Am I audible now?
Yeah.
Yeah.
Yeah. Okay. So who operates the relay? Relay is operated by the person who actually wants to transact Tezos from Tezos blockchain to Cosmos blockchain, and it's the person who is running the peg zone. doesn't need to run really the relayer, but the person who wants to transact needs to run the relayer as well as the peg zone. He doesn't need to run it, he just need to have the binary of it. And do they need to run both Tezos and peg zone nodes? No, for Tezos node they don't need to run, but peg zone node, yeah, they need to run it. For right now what the architecture is, they need to run. Yeah.
Hey, Dennis here. Just a follow-up question. So
yeah.
Okay.
For me, for example, if I want to transfer tokens, I would have to either run my own relayer or trust another person to run a relayer for me. Right?
No, if you want to like really transfer your token to Cosmos blockchain, you need to run your own relayer for that. You cannot like trust other people's relayer, like as per my architecture, I think, right now.
Okay. Thank you for the answer.
Yeah. So
Thank you for the questions. Any more questions? I think that's it. Thank you so much for your presentation.
Yeah.
Billy has a question.
Billy has a question.
Oh, great. Awesome.
Right.
Hi there. Can you hear me?
Yes.
Yeah, I can hear you.
Hi. Super cool project. I'm just jumping into the code a little bit because you were cutting out and I wanted to see how the thing's working. I'm inside of the execute messages.go inside your keeper. There's this verify Bifrost FA12 TXs.
Yeah.
It says it dials the operation engine on relayer with verify instructions. I was just curious, could you talk a bit about how do you verify a transaction came from
actually
Tezos chain?
So right here the verification means we actually need to see if the transaction exists in the Tezos chain. So when it dials the operation engine or verification engine, the verification engine sends back whatever the transaction is currently in the storage. Right, with that the transaction received matches for now. The first step. That's what the work.
Is that not an asynchronous, like non-deterministic operation?
No, I don't think so, because the way relayer transmits message, it transmits a message to get executed, and then it relays the acknowledgement fail or then goes back to the next transaction. So until the transaction executes fully, the transaction is there in the Tezos storage, right? So it's
it's breaking up. I'm sorry, I can't hear you at all. Maybe we can chat about it sideways. It's a technical detail, but I'm curious to hear more about it.
Okay.
Yeah, sure. I'll say about it. Yeah.
Our time's run out for Bifrost as well. So maybe guys, let's just chat in the group. Thank you so much for joining us. Yeah. Congratulations, Bifrost.
The next team will be CertEx. Let's get the speaker on the stage. Belzy? Yeah.
I think you're on mute, Belzy.
I think you're on mute.
Hi, sorry. We could also share the video file for the demo.
Yes.
Okay. Do I have to play it immediately, or can I play it in a second?
You can play it later. I mean,
okay, cool. So I'll share my screen first. Screen. Can you see my screen? Oh, okay, great.
Yes.
So my name is Belzy. I'm from the CertEx team. CertEx is a project demonstrating the usage of IBC to communicate between different zones. And the business domain here is privacy preserving credential management. We'll demonstrate 2 use cases, but before we jump into that, just a bit of background on credential management. So credential is in the physical world, maybe a certificate from a university. And then sharing this credential on the internet is not new. So w3.org has this diagram on verifiable credential. Basically, the verifiable credential is just the information on the physical credential plus a signature from the issuer, so then people could verify that data. So in terms of the role, the issuer would be, say, like a university, issuing a degree to Alice, who might have been a student, and then Alice wants to send this degree to be verified by, say, maybe her potential employer. And in the sort of in this model, Alice is one identity, and also everything goes through this verifiable data registry. So in the world where we want to be able to preserve people's privacy and sort of want to decentralize data registries and really sort of increase usability, CertEx proposes this method. So the issuer, say the university or government, healthcare, they in the future could operate within their zones, and it could be a private blockchain. They're not, open to other people, and the verifiable data registry sort of becomes split in terms of having people who are able to create and provide the proofs, and then submitting a representation of that credential, so only part of it or an encrypted form, to the proofs provider. And in this case, Alice actually holds a credential wallet where she could generate decentralized identifier DIDs on the go for when she needs to. Just to minimize the confusion as well, we've sort of named the proof provider, in this case CertEx, as well. So the first use case here is Alice wants to go to a restaurant. She's a muggle, she's non-magical. The restaurant doesn't really need to know anything about her apart from the fact that she has been vaccinated, perhaps a vaccine passport sort of use case. So when she gets to the restaurant, she generates a new identifier and basically signs that and asks the health authority to send it to CertEx for the restaurant to verify. So I'm going to see if I could play that video. Can I? Blockchain's running. We've got the muggle auth. We've got the Mystery Magic, and then CertEx on this side. And so here we have the relay setup, where it's not running at the moment. But first we want to look at basically what are the records currently in the MuggleD auth blockchain. And we have one record with the holder and sort of the issuer. This doesn't really mean anything until we look at who these people are. So for the purpose of HackAtom, the Alice and Health auth have the sort of the same file storing the keychain backend. We can see that Alice here is the holder of this record, and this record is an ID 0. So now we have gone into Alice's space, and we're thinking of Alice arrived at this restaurant with the DID of restaurant number 81. She knows the ID of her record. That doesn't really have to be like that. And this transaction is going to do two things. It's going to first create a new DID for Alice, specifically for this restaurant, and then also send an IBC message to CertEx to record this credential. So there it is. We're going to send this message over. Now, first we want to check that. Now there is a credential on the other blockchain, which there is, and the issuer is the same as the issuer of the credential here. And then we also want to check that there is now Alice actually has access to these new DID. And the name is the same, it's sort of like to identify the verifier, so the name is the verifier, and she has sort of like a new address. And this is actually the address that is being used as a subject on the CertEx. So there's nothing really linking Alice on the Muggle blockchain to to this record here. Okay, can I share my screen for the for the next use case? Okay,
Sure.
great. So that was sort of a simple plain text credential on CertEx use case. The second use case here is what if the data is a little bit more sensitive? So in this use case, Alice is magical, and she's worked at the Ministry of Magic, and she has an employment record there. She now wants to apply for a role on a Quidditch team, and she basically wants the Ministry of Magic to provide that employment record. So when she creates a new DID and asks for this record again, she will also send over a encryption key. So the Ministry of Magic blockchain would encrypt that record and basically send it back to CertEx over here, and CertEx just stores it. Whereas in the previous use case, CertEx actually verifies that signature as well. So now she could share the key with the Quidditch team, so then they could decrypt that record, or she could share it basically with anyone. It's now stored on CertEx. So if I could play the video, please. Thank you.
Thanks, Kelsey. So we'll come to the questions from the judges.
Sorry, I have the second. It's not playing. Can you hear? Try removing. Oh, there we go. Oh. Okay, I'll just quickly talk over it. Basically, when Alice is trying to send over this record, the first line here is the private key. Sorry, it's a symmetric encryption key that she would then go and share with the Quidditch team in order for them to decrypt the record. And this is sent over to CertEx. Here, we basically just copied and pasted the key for the Quidditch team to see. So the message here prints out the decrypted version, and the claim is encrypted over there. And for some, we also actually have the signature in the message. So then it was verified to make sure that it was actually sent by. It could be used to verify that it was sent by the issuer. Yeah.
Great, thank you. Thank you so much. Judges, do you have any questions? If you have any questions, please leave us a chat and we can. Okay, Billy has a question. Great.
Hi there. Great presentation. Fantastic use of Harry Potter references. I just wanted to ask about the second scenario when you're passing around keys for signing and encrypting things. Was it correct that Alice will send a private key to the Ministry of Magic to use, and they will sign with that key?
Yeah. So Alice generates a key that she uses to sign. There's sort of the use cases so that she could sort of share it or pre-generate that. Maybe the verifier wants that to be something, but as part of sort of DID communication, really the communication between Alice and the Ministry of Magic should also be encrypted with her DID already. So that was we didn't actually implement the DID document, so that communication is just through TCP. Thank you.
Okay, cool. I was just
Does that? Yeah.
I think so. I was trying to understand if it was just the idea of sending a private key anywhere seemed dangerous, but I think I misunderstood it then.
Yeah, it's AES encryption, so I guess it's not quite as dangerous as a private key, I guess, but it's the metric. So so both sides would have to have the same key at some point. And I don't think we could let the blockchain indeterministically create one at the time. So yeah, that's the solution I got to.
Cool. Thank you very much.
Thanks.
Thank you, Billy, for the question. Any other questions for Belsey? Okay. All right. Thank you so much for the presentation. Thank you.
Thank you.
All right. Now we have our third team, Interstellar.
Hey guys,
Hi, Max.
Hello.
Nice to meet you.
pleasure to be here.
Thank you for being here.
So do I start?
Yes, the stage is yours.
All right. So let me share my screen real quick. Here, so I'll start. Hello, welcome. We're Team Sapiens from Korea, and over the past 2 weeks, we have developed Interstellar, a lending platform using the Cosmos SDK. So Interstellar provides lending and borrowing services for any assets on a chain that support the IBC protocol, both fungible tokens and NFTs. So it really has two main functions. The first, depositing and lending IBC assets with a dynamic interest rate by using IBC protocols. The user is able to deposit one asset into a pool, earning interest in the process, and then borrow from another pool to a certain ratio using their deposit as collateral. And secondly, we also support the user receiving loans for his NFT. NFTs are able to be used as collateral, and while other users can offer loans in a peer-to-peer fashion. So what inspired us to develop Interstellar? We think that the Cosmos ecosystem is unique in the blockchain space in that it provides a wide range of opportunities with inter-blockchain communication. But it is currently missing a proper medium to borrow assets across the different IBC-enabled chains. So Interstellar aims to be that medium and to unfold the potential of IBC by enabling cross-chain lending. And also, we aim to tackle the NFT market as well by providing a way to effectively utilize NFT as collateral. We aim to build a foundation for a flourishing NFT market in Cosmos. So now we're going to go on to the demo. Let me change my screen. Here. Right. So this is our main page. I'm logged in with an Alice account right now. I'll start with a brief explanation on the UI before I deep dive into the features that's in our webpage. So on the very top, we can see the user's deposit balance and borrow balance on our chain, which is $0 right now because the user hasn't done any actions right now. And below that, we have the deposit pools and borrow pools, which are consisted of assets from the Cosmos ecosystem. So I'm going to start by borrowing Atom from the deposit pool. So I'm going to borrow 1,000 Atom for test purposes. Taking some time. And then now I'm going to borrow like 50 more AKTs. So yeah, on the top, we can see that I deposited AKT and Atom, and I have my deposit balance on the top. And also, I can see my current net APY on the right side, which is calculated by block height. And on the right side, now I'm going to try to borrow Iris. So the main concept of Interstellar is cross-chain lending system. So even though the user deposited AKT and Atom, they can use it for collateral to borrow Iris or any other assets that's existing in the Cosmos chain. So I'm going to borrow it. And there is Iris in our account. And we can see that our borrow balance has also increased, while the wallet's asset amount has also increased as well. And also, we have a main feature. In the while I was talking, we can see that I was able to obtain interest. It's a little bit, but still, So now moving on to the second feature, not only users can use assets that's available in the Cosmos ecosystem as collaterals, they can use NFTs they have as collaterals as well. So this is the NFT dashboard that's existing in our chain. So I think this one is a great art piece. I'm gonna try to offer him like 10 atoms for 15% interest for 14 days. So that's how I make an offer for this specific NFT. And if the owner of the NFT thinks that this is a good offer and he needs a loan somehow, he will probably accept it. So yeah, I'll be waiting for him to accept my offer so that I can give him a very good deal loan. Yep, and screen. So back to presentation. Just a moment. So what's next for Interstellar? We're planning to add custom tokens in order to incentivize protocol usage. We're also going to use the tokens for allowing custom token staking and fee paying as well. And also we're going to allow custom tokens for loan for NFT collaterals as well, while we will wait for the Cosmos ecosystem to adopt a consensus on an NFT module to support cross-chain IBC NFTs as well. So that's it. Thank you.
Thank you. Oh, he left. Where did he go? There are questions.
Hi, Max.
We got to bring him back.
Sorry.
Where did you go? Okay, we have plenty of questions right now. Okay, let's bring them up.
All right.
Hello, everyone.
Hello.
How people can evaluate the owner NFTs? Do you think you should integrate some Oracle sources, API, such as from the centralized finance service in your system to evaluate the owner NFT to show more information for the lender in case they don't know the value of the NFT?
Mm-hmm. Yeah, that's a very good question. I think you asked about like how NFT values would be evaluated, as they don't have a fixed value in the beginning. So
yes.
So what we're trying to do here is we're trying to make a marketplace for NFTs as well. So people are gonna evaluate their assets based on the offers. So for example, like let's say NFT A is worth $10 for me, then I'm gonna make an offer. And then in that way, by creating a marketplace where people would actually propose offers, we will be able to get the average price of the NFTs, and therefore we'll be able to value the NFTs. If that makes sense?
Yeah, okay. I think that's good.
Okay.
Those are offers to buy the NFTs?
Actually, no offers to buy the NFTs, but offers to offer a loan for NFTs, which would after the certain amount of time, the NFT would automatically be transferred to the loan offerer's account. So it's it's not actually buying, but it's being used as collateral and being transferred after if the user doesn't pay back his money. Yeah.
I have a question about how the protocol manages the accounting and how it allocates interest rates. So you said that somebody could deposit Atom and Akash while earning interest while borrowing money, and so how? What's the mechanism in the back end?
Right.
It's meant to be used as collateral, isn't it?
Yeah, right. So that's a very good question as well. So in principle, all borrowers are compensate all depositors by paying interest. So a base interest rate for depositors is set at a certain target borrow ratio. Well, and if the borrow ratio is above the defined target borrow ratio, depositors get incentivized more and vice versa. So the future Interstellar token that we plan to integrate will be used to incentivize the protocol usage as well, more by providing rewards for both depositors and lenders. Does it make sense?
So does it matter what token that they deposit? Like, you know, if I deposit Iris, would I be earning Iris interest, or like what determines what interest in what coin I get?
So for the deposit, I would be earning interest depending on the deposit I made. So if I made an Iris deposit, I would be earning interest based on the Iris deposit I made, because the asset I put in as deposit is going to the deposit pool and staying there until I withdraw it.
Okay.
Right.
But does that mean that it has to be actively borrowed in order for that borrower to be paying the money, which would go to that lender and interest? Or if there's just a bunch of deposits there, but nobody's borrowing it? Yeah.
All right. Sorry. Can you say it again?
So we've got a bunch of people who deposit, but nobody's borrowing. There's going to be no interest earned on those deposits until somebody starts borrowing. Is that correct?
That's actually correct.
Okay.
Awesome.
Did you finish your question, Chenko? Cool. I just want to jump back to the NFT thing for my question. So it was just a little confusing to me a couple of times that it was said, because the word lending and borrowing is such a weird flip-flop between the perspectives. So I want to just confirm that I have it right, and I think that you did a second ago, but it's more like a pawn shop that I could lend out my NFT for some amount of fiat, or sorry, fungible token, and I would be able to get back my NFT if I pay that amount of token back plus some interest.
Right. Correct.
Okay, and when I do that, the chain itself is determining the value that it's willing to lend me for that NFT.
Actually, no. The person who's making the offer is determining how much the NFT is worth, not the chain itself.
But then I could come in with a worthless NFT and say, this is a really valuable NFT. I could take the loan and I could never pay it back because I don't care. I just got rid of that worthless NFT and I made a bunch of money with it.
That's true as well, but that's how NFTs work, right? The market decides the value of NFT, right?
Right, but in like a pawn shop scenario, you have a human being who's saying, hey, best I can do is $200.
Right. So if someone makes an offer, the owner of the NFT gets to decide whether he's going to accept the offer or deny it. So the owner of the NFT can decide as well whether they're going to accept it or not. So that's yeah.
So it's peer-to-peer then. It's not against the protocol itself.
Right. It's peer-to-peer.
Cool.
Yeah.
Cool.
Thanks.
Awesome. Thank you all for the questions, and thank you, Matt, for the presentation.
Thank you.
Thank you so much. Thank you.
Oh, also,
right.
there's updates on the NFT resolution. Check the GitHub issue. We're much closer to being on the same page.
All right, thank you.
All right. Thanks, Billy. Thanks, Matt. All right. Next up, OriChain. Did I pronounce it right? Let's get him on the stage.
Yep.
Hello.
Hi, too.
Hi, too.
Hello. Hi, everybody.
Hi.
Thanks for being here.
And let's start our presentation. Sure. Yeah. Can you see my screen?
Yes.
Okay. So our presentation started. This is OriChain. Actually, we already have the launch product. It's AI Write, and we are going to improve this with IBC. This is based on the IBC and NFT exchange for Cosmos. Our vision is we will support all blockchains in Cosmos hub with no border among different blockchains. Allows user to buy, sell token. This will allow user to swap a token transparently with the support of the IBC. And we also support other blockchains, including Ethereum, Binance blockchains by building the layer. Other features, including we will support multiple wallets, such as CapR, Key Station. We will support automated market maker and multiple assets, such as ERC20 or EP20. And we deploy to all the marketplaces with the OriChain ecosystem and AI rights. I will show the demo. This is the code base, and we have two blockchains, the Mars blockchain and the Earth blockchain, and we will allow user on the Earth blockchain to buy NFT on the Mars blockchain. As you see, this is the information of the blockchain. It's a LCD of the Cosmos SDK. Yeah, to see the new blocks. And here you see we have two accounts. Let's say the account on Earth blockchain and Mars blockchain. And first we will create a new NFT on the Mars blockchain. Set the price, and then we submit. Because we set the 5 seconds for block confirmation, so we have to wait about maybe 10 seconds. And after we have sell NFT successfully, we will see it's a list on the marketplace. This is a new NFT. And next we will open it and buy with the account from Earth blockchain. As you see, we will buy. Here we have two native tokens, Earth token and Mars token. Because we use IBC swap, so we can use directly Earth token on the Mars blockchain, thanks to the IBC SDK. And after we buy it, you see it's no longer listed on the marketplace. And we also have we can search the transaction using the LCD with a contract address. This is very powerful API from the Cosmos API. We can filter anything we want. Such as we will filter all the by transaction. Yeah, you see this is a native token from Earth blockchain that we sent directly to the Mars blockchain. With the traditional way, we have to build a bridge to allow user to swap a token from other blockchain into the Mars blockchain, and it takes time. And with the IBC, we can do it naturally, transparently, and we also have Oracle service, which help us to set the price for each token pairs using the Bifrost AI Oracle service. Here we because this is already launched product, so we just we not focus in depth with low-level knowledge. We just focus on the proof of concept, and we are going to learn this down the road, and then maybe next month. And that's it.
Great. Thank you so much.
Yes.
Okay, Peter has a question. Billy has a question. Let's bring them up.
Hello, everyone. I know you built an NFT exchange from two blockchain that implements IBC in Cosmos. But if you build NFT exchange from the Ethereum blockchain to any IBC, some blockchain implement IBC, this is a problem. Do you think about your projects compared with interchange NFT project that some workshop that are introduced about it? They build a common standard about the NFT that can connect cross multi-chain. How do you think about that?
That you mean the multi-chain cross NFT? Actually, we already have the bridge that allow user to swap the NFT from other blockchains such as Ethereum or Binance to swap the NFT into our blockchains. We have our own blockchains, and you can check it at the AI right. Yeah. That's another bridge. Currently, IBC is not support it, so we have to build a bridge. We just follow the standard.
Yes, and that means we also already had a project named Interchain NFT that they build a common standards about NFT that can communicate across multi-chain. I think you must research about that project. It is a good idea to build the NFT exchange from the multi-chain. Yes.
Yeah, thank you. That will be helpful for us because we are working on it. Yes, thank you very much.
Okay.
Hi, thanks for the presentation. I just wanted to confirm I understood some of the pieces of it correctly. It's a CosmWasm based blockchain using the CosmWasm NFT standard, yes?
Yes, we use the latest version 14.0 from the CosmWasm.
And does that mean the CosmWasm, I know that they've been working on this, but I wasn't sure if it was finished. Is the IBC CosmWasm application layer protocol completed? So you have arbitrary contract calls transferred over IBC, or is it bespoke, like just for NFT, the IBC standard?
Yes, actually, you see now the latest version support the ICS 20 in CosmWasm. It means that we can build the token smart contract that allow user to transfer the token from one blockchain to another directly. But this smart contract we modified a little bit that allow user to send the native token. So it depends on user.
Okay, so when you executed the buy NFT between the chains, it wasn't a buy message that was sent over IBC. The person bought it and then transferred it with a token transfer over IBC. Is that correct? Or was the IBC message a buy?
Yeah, actually, we just use IBC as the transfer as the method to swap native token between two blockchains transparently as the blockchain layer. We use IBC transfer.
Great, thank you very much.
Okay, great. Thank you so much for the questions, and thank you too for presenting. Thank you so much.
Thank you, everybody.
Bye. All right, next team is NFT Stay. Tristan, you're up. Hello, Tristan. You're on mute, so can you try unmuting yourself? You're on stage, so. Is Tristan gone? Tristan, can you join us? Maybe.
Can you?
Oh, there we go. There we go.
Can you see me?
Yes.
So, sorry for late.
No worries. Thank you for being here.
You know, it will be a surprise me when I received the new email confirm that I can join the demo day today. Very surprised me.
Thank you. Can you give us a summary and do you have something ready?
Yeah, but I want to say sorry first because it's very short time to repair it. So yeah,
No worries.
today but I still upload the demo video on the dev box.
Okay.
So let's start. Yeah.
Sure. That's the HackAtom spirit.
Mm-hmm. So I call my project is NFT Stay because the inspiration from because I have worked on booking system and OIT system, and I realized the potential for hotel rental is very huge. So I want to build the marketplace to user can create assets and sell, buy, or transfer orders. And yes, I utilize some technique of commerce like customer IBC and you know Starbucks framework, and I also use some service IBFS to store metadata. So yeah, very simple. So I want to share the video demo to show functions. Yes, I can share screen now.
Let's wait a second. You can press share.
Share, yes.
Great. Yay.
Yes. This video I upload before 1 hour. Let's start. So can you see my screen?
Yes.
Okay. The first case it will be created. The user can create NFT Stay for some people can buy it, and it means the owner can can have permission to stay if they own assets. So after user create entity, and we can burn it or sell on the market. We have two options to sell on the market. One of fixed price or one of auction. So this is NFT storage where I can reuse IPFS. It's been the image or token info. I also upload it to there. You can see this is metadata of assets. And which I upgrade a new auction. We can set the expiration time. And you see it appear in the market. And the buyer can play a pick to join the auction. And after expiry time, the target bid will be can be claimed. So use case by fixed price directly by. You see, after by it's the owner, on the buyer. And the next features is transfer. The system can transfer on-chain or cross-chain by using Cosmos IBC. This is the demo for transfer on-chain. This is Bob, and he have new assets when we receive. And the next case, we can change for the system can allow user send NFT cross-chain. Hold it. So let's I explain here. Um, we are demoing two blockchain. One blockchain or blockchain, and one blockchain is Max. You know, they are running different board. The the chain running A1 A0 A0, and the smart is running A0 A02. You see it's here monster, and this guy demo for Alice from Art send asset to monster on Max. See. And you see the monster have received new assets. You can see the address here, stay and channel 0, and the rest from Alice. That's it. It's on basic function to learn Cosmos SDK, and using Starbucks to build cross-chain solution. Yeah.
Thank you. Thank you so much. All right. So Peter has a question. Billy has a question. All right, let's bring them up.
Hello, everyone. I think this a good idea when you combine the blockchains and distributed database like IPFS for storing metadata. But who hold the IPFS nodes, and what incentives the owner of the nodes yet? And the next question: if someone,
sorry for interrupt, because the network interrupt, I can now hear the reverse question. Can you?
Okay. I think this is a good idea when you combine blockchain and distributed database like IPFS for storing the metadata. But who is the host of the nodes, IPFS, and which is incentive of the host of the nodes? And the problem here, when you mapping NFT with the real world business, if you have a news about your department rental, and someone clone this information, and they create another NFT, and someone buy NFT and pay fee for them. How to solve the problem?
Yes. Okay.
Okay.
Thank you for your question.
Yeah. Okay.
Okay. Let me answer the one the question one. As you see, I'm using NFT.
Did something happen to the?
Storage. Sorry for network. Because I using NFT dot storage. It's a project open source and rapid IPFS storage, and it's running on beta version, not official, I think, and it's the NFT doc storage make user make developer easier to interact IPFS. But mechanism behind the scene NFT storage, I couldn't research deeply on it, but I just know the service to use IPFS, and very easy for developer to interact with.
Yes. When you use the IPFS technology, it is P2P technology. It needs more than two nodes to hold the technology. Okay.
Yeah.
And you talk about the roadblock in a real world business about someone clone your NFT about information and make sell on it.
It's a common problem here. So I think now I think the world is find the solution to solve. I cannot so really
That you must you must prove that digital asset belong to you. Okay.
Okay, Billy, did you have a question as well?
Yeah, hi. Thanks for the presentation. It looks like you've really onboarded a lot of how all this stuff works. It's really impressive. I'm just jumping through some of the code, and I'm trying to understand. It looks like you built a new IBC packet type for NFT transfers. Is that correct?
Yes.
That's really cool. So this is similar to a standard transfer, but it's NFT one, and it utilizes the underlying, IBC client 02. I'm just jumping through the code and wanted to make sure that it was a new IBC packet type instead of using the fungible token transfer. That's really impressive. Thanks very much. I guess that answered my own question.
Thanks, Billy.
Okay. The last question. How about the advantage and disadvantage of this model compared with the centralized system? If you don't use blockchain to carry out this model, you still carry out this model in a centralized system. Do you think so?
Sorry, I don't understand what you mean.
Yes, if you because you use NFT because you use NFT for that project. If you don't use blockchain, you build this system like traditional technology, like centralized system. What is the difference from this two model?
Because if it's a centralized system, it's like the all system and the owner system can do everything on it. It's not it sometimes not transparent if we deploy on decentralized, and I think that it's will be transparent model.
Okay, that's okay.
Great. Thank you so much for the question, and thank you, Tristan, for the presentation. Thank you so much.
Thank you.
Thank you. Yeah, so thank you all for the presentations. We had a lovely time. We also had Cosmos Pond to do a demo, but due to different time zones, we really couldn't have them to do a live demo, but it will also be included in the judging category. So now judges will have a deliberation session. So judges, you can join your Zoom session now. And in the meantime, we can watch some introductory videos prepared by our wonderful sponsors. So I will see you in a bit. Thank you.
Hello, everyone. My name is Kyo Lee. I'm the CCO of HCMC Technology. We are pleased to be a sponsor for HackAtom HCMC 2021. HCMC Technology is currently preparing to launch our mainnet, Ryzen, which will use the Tendermint core and Cosmos SDK. But I'm also a big fan of Cosmos personally. Before the launch of Cosmos Hub, I wanted to make a playground for Korean Cosmos community, which led me to develop a website called cosmostalk.io, which was named after bitcointalk.org. It was with a few Korean blockchain researchers. Although we put that project away, now that we are in the middle of crypto summer, I believe Cosmos has a great potential. And I think you all made a wonderful choice to use Cosmos to build your decentralized projects. On behalf of HTOP Technology, I hope HackAtom HCMC can be a small but meaningful step for your journey. And I hope your team achieves huge success, not only as a blockchain project, but also as a tech company. So now I'd like to talk a little bit about my company. We had our ICO back in 2017, and since then we've been working on developing our mainnet. As one of the leading blockchain development company in Korea, we have thought deeply about ESG, environmental, social, and governance criteria in the blockchain industry. And we've been worked really hard to design our services to align with these values, which is one of the reasons why we've changed our consensus algorithm from POW to POS. Since the start of our preparations to launch our mainnet, we've observed every fad in the blockchain scenes, including DeFi's, NFTs, metaverse, DAOs, social tokens, stable coins, and so on. However, in order for these blockchain-based services to be most effective, we need to encourage the larger public to adopt them. That's what makes our company stand out from others. HTOP Technology is backed by HCMC Group, formerly Hyundai BSNC, which is one of the biggest companies in Korea. Our connections with well-established companies can allow our services to be readily adopted by the general public. We've been working really, really hard, and the launch of Ryzen, our mainnet, is just around the corner. Every validator and developer is welcome. If you're looking for an opportunity to develop a business in Korea, Ryzen will be a best choice for you. Once again, thanks for having us, and I wish you the best of luck. Thank you.
Hi guys, hope you had a wonderful time hacking away at the HCMC Cosmos Hackathon. We were a silver sponsor for the hackathon. We have previously sponsored a hackathon in Seoul before, last year. So yeah, hope you had a wonderful time. And for those of you who are not familiar with Cosmos Station, we are a validator node operator in the Cosmos Hub, Iris Hub, and several other Cosmos SDK based networks like Band Protocol, Kava Network, and Crypto ORG Chain, and also several other networks outside of the Cosmos ecosystem like Chainlink. And we also provide a lot of end user applications like our mobile wallet, which is available in iOS and Android. And we have an explorer called MintScan. The front end part of the Block Explorer is open source. So for those of you who are interested in building out an explorer, front end explorer, you can feel free to take a look at that and build your own. The mobile app is actually both iOS and Android are also open source, so you can take a look at that as well. And we also provide a web wallet with a Ledger integration, and also with a product called KeyStation, which is our own end-to-end encrypted key management system. So yeah, if you're interested in what we're building and what we've been up to at Cosmos Station, you can visit cosmostation.io, and everything's outlined there, our team members and our GitHub profile. So yeah, feel free to take a look at that, and I hope you had a wonderful time at the hackathon. And if you want to continue building in the Cosmos ecosystem, we're always open to a discussion. If you have any questions regarding our Cosmos JS library, please send us a message on Telegram or our official Twitter. We're always here to help and expand the Cosmos ecosystem. Hope you had a wonderful time. Bye-bye.
All right, and we're back. And we have the winners. Ready? Are you guys here?
We're all here.
All right. So first place, sorry, well, you know, we're going to go backwards. Okay. So third place winner. Ready? Ready, ready, ready? It is Bifrost.
Woohoo! Congratulations.
All right, congratulations, Bifrost. You are in third place. The second third place winner, there's two third place winners, NFT Stay.
Woo! Congratulations.
And second place winner, ready, ready, ready? CertEx.
Yay!
We need a real drummer here. Erica's the hype man. And first place winner, are you ready for this?
10K.
First place. Yeah, $10,000 for the big kahuna. Who could it be? Well, none other than Interstellar.
Woo! Congratulations.
Teams, you have done such a great job. The judges finished deliberating and thought that this was the order in winners. And so if you are a winner, please come and contact me. Yeah, you can contact me. Please see my contact information. With Erica has my contact information, and we will, you know, process your Atom winnings. And we also are deliberating on Tenement Fellows. So if you want to become a Tenement Fellow after you've been received an offer, yeah, let us know. We'll offer it first, and then you let us know if you want to accept the offer. Yeah, the way a Tenement Fellowship works is it's a monthly program. You get a stipend for continuing to commercialize your product until it's mature enough to go into the real world. And so some of you here have actually developed something quite interesting with a lot of potential, even though it's a proof of concept. And so in the future, you know, we might want to help you develop it further to productionize it. So that's what's happening. And congratulations, everyone. What a great job you did. This is very excellent. We're very pleasantly surprised because this is our very first HackAtom in Southeast Asia, even though it's all remote now. But this is really great. A bunch of new teams and new faces came, and we're very excited that you were able to pick up the Cosmos stack so quickly and develop something that is so useful and creative. Lots of original ideas and lots of innovation happening here. I think there's a lot of talent all around the world, and these are what this is what the HackAtom is used for sourcing. So congratulations, everyone.
Thank you, Chango. Thank you.
See you in the next one.
Yeah, see you in the next one. Thank you, guys. Thank you, everybody.